Can anyone tell me what is the addition rule of counting? Just you don't need to say the definition, just roughly whatever you have understood, just tell me what is the what was the addition rule of counting? None of you can remember. Am I audible? Can you hear me?
Yes, sir.
Yes,
Yes,
I
sir.
audible.
So what was the addition rule of counting? Have you forgot? You have told that you don't have any problem or doubts. Have you forgot? None of you can remember. The addition rule of counting is actually if we could choose some certain element from a set in n1 ways and we could choose another certain element from another set in n2 ways, then either the element can be in a1 or can be in a2. We can choose in n1 plus n2 ways. That means there are two different sets where there is no common elements. So if I need to choose a element either from this set or from this set, so total the possibilities are n1 plus n2. And if they are independent and if I can choose one element from first set and depending on which I can choose the second element from second set, then total there will be n1 into n2 ways. Okay, is that clear or not?
Yes, sir. Now clear.
So what is the inclusion principle? Say for example there are two sets, let us say this is set a1 and this is another set a2. So a1 and a2 are not disjoint, a1 intersection a2 is not equals to 5. So if I need to choose a element from a1, say number of elements in a1 is actually n1 and number of elements in a2 is n2. So let us say I need to choose a element from a1, either from a1. So what is the problem? I need to choose element from either a1 or a2. Then what is the total number of possibilities? This is your problem. So here unlike the addition rule where we have used, so a1 a2 are not disjoint. So either we could choose a element from a1 or we could choose a element from a2. So if they were disjoint, say a1 and a2 are disjoint, then what was the total possibility? Say this is a1, this is a2. So if the elements are a1, n1, the elements are a2. So either we could choose from here or we could choose from here, will be total possibility n1 plus n2. But here if I choose a element from a1, then it can be here or it can be here. So if it is here, then it may belong to a2 also. So there are some common portions in between a1 and a2. So whenever we are actually finding out the total possibilities, then this will be n1 plus n2 minus we need to consider the total number of elements which is there in a1 intersection a2. So we need to discard this, because otherwise whenever we are choosing some elements from a1, we are choosing from the common portions. Similarly, whenever we are choosing an element from a2, then this might be there in the common portion. So the common portions are counted twice. That's why we need to subtract this. Is that clear? Is that clear or not?
Yes.
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
this is called as the inclusion exclusion principle. That means whenever we are choosing an element from here, we are actually including that. Similarly, whenever we are counting a2, we are including that element. So we need to exclude the elements which we are taking twice by subtracting the total number of elements which are there in the intersection of two sets. So this is called as the inclusion exclusion principle. Is that clear? Is that clear?
Yes.
So I am not
Yes,
writing
sir.
it here. So in different books, whatever I have given, you will be knowing the definition. So if it is asked in the example exam that what is the inclusion exclusion principle, so you need to say tell that. So let's say there are two different sets, a1 and a2, where a1 intersection a2 is not equals to 5. Then if we need to choose an element from either a1 or from a2, then total number of possibilities to choose such an element will be n1 plus n2 minus intersection of total number of elements which are there intersection of a1 and a2. So this is the inclusion exclusion principle. So just I want to give one a simple example, then it will be clear. So since you are studying in computer science, so let me consider one example which is actually inclined to that. So the problem is how many
স্যার একটু স্কল আপ করবেন।
হ্যাঁ sure. আমি দিয়ে দেবো এই নোটটা গুগল ক্লাসরুমে, বুঝতে না পারলে জিজ্ঞেস করো, না হলে এটা লেখার দরকার নেই, কারণ আমি তো এটা দিয়ে দেবো এমনি গুগল ক্লাস। I think you have got the previous two notes, which I have shared in the Google Classroom. Just you need to create an account in Evernote.
ইয়েস, ঠিক আছে।
So how many bit strings of length? So do you know the question pattern of first mid semester examination?
No, sir.
No,
Question patterns will be, there will be no alternative questions. So the questions whatever will be given to you, you need to answer all the questions. So only for 10 marks questions there will be alternative. So there will be total 5 questions, each of 2 marks. So there will be subjective questions, that means 5 questions, not MCQ questions, 5 questions each of having 2 marks. That means some this kind of definitions might be asked from my part or like that. That means the definitions or some certain justifications, that type of problems will be given. So there will be total 5 questions of 2 marks, so total marks 10, and then there will be 2 questions each of having 5 marks, so total 5 into 2, that is also 10, and then there will be 1 question of 10 marks. So there you will get an alternative. So there will be 2 questions, so out of which you need to answer only 1 question of 10 marks. So total 2 marks questions there will be 5, so total 10. 5 marks questions there will be 2, you need to answer all the 2 questions, so that is 10, and there will be an alternative in 10 marks questions, you need to answer only 1 question, that is of 10 marks, so total 30. Okay, so this I know,
Yep.
but if it changes then we will be able to know from your subject teachers, that means from Raina ma'am or Isa ma'am, but whatever
Overall 30.
yeah, overall 30. So this holds this happens for BTech and other streams, BCA, MCA, BCA, MSc. For MC I think this sort of pattern will be followed, but if it is changed slight bit, then your teachers, subject teachers can tell you, but roughly whatever as per my knowledge of
আমাদের এই চ্যাপ্টারটা তো মিড সেমে আছে।
Yes, yes. So in midsem there are you have got the syllabus in the Google Classroom also, there is a syllabus. So first and second module. So that means the algebraic structure which Anubhav sir is taking, and I have already discussed the number theory, then the permutation and combination part, and the graph theory portions which is discussed by Krishan sir. So all these things are there in first semester. Okay. So overall entire portions might not come. So if I finish whatever I will be finishing by today will be there from my part. Whatever Krishanu sir will be finishing before the first mid semester, that portion will be there in the first mid semester. Is that clear? So say for example entire module 1 and module 2 are not finished in first mid before the first mid semester, then the questions will not be coming from the entire portion. Okay. Is that clear?
Yes, sir.
Okay, sir.
স্যার সাজেশন দেবেন না?
মিড সেমের আগে যদি মানে সিলেবাসটা যত আপনারা করাবেন যদি একবার রিভাইজ দিতেন তাহলে সুবিধা হতো।
রিভাইজ মানে আমার তো সবই বলা আছে এবং লিখে করিয়েছি, আমার আর রিভাইজের কি দরকার? না আমি তো নোটগুলোও দিয়েছি, এমনি যেগুলো অফলাইন ক্লাস নিয়েছি তখন তো সব প্রায় প্রুফগুলো করিয়ে দিয়েছি, প্রায় করে দিইনি?
হ্যাঁ স্যার।
তাহলে মানে আর রিভিশনের কি দরকার? সেগুলো নিজেরাই পড়তে পারবে, রিভিশন কি করবো? না আর কিছু রিভিশনের কি দরকার বুঝতে পারছি না।
লেন্থের পার্টে কি লিখেছেন স্যার? স্ট্রিংস অফ লেন্থ
বলছি how many bit strings of length 8?
ওকে স্যার।
So how many bit strings of length 8 either start with a 1 bit or end with 2 bits 0 0? That means we want to frame one string of length 8 bit. So what are the possibilities? So here either or, that means there are 3 possibilities. What are the 3 possibilities? I am asking to all of you, do you think that any suggestion or anything is needed from my part, because I have already discussed all these things and the proofs which are required I have discussed in the
Yes,
class.
sir.
So that sort of
Give
problem
us
will be
some
coming.
practice sets. That will be helpful.
Yes, ma'am.
So I have to discuss all the problems. So what sort of problems? Say for example, the permutation combination. I am discussing one or two problems. So that kind of problems will be coming. So you need to practice that. Otherwise, if you wish, I could provide some problems in the Google Classroom.
Yes, sir. Please provide some problems, sir.
But it is not like that. The problems which I am giving, from that the problems will be coming. That sort of problem will be coming. But exactly the same problem will not be coming.
Okay, sir. No problem.
Okay, so a problem to pose, how many bit strings of length 8 either start with 1 bit or end with 2 bits 0 0. That means, say this is a length of 8 bit string. So either it can start with 1 or it can end with 2 zeros, or it can end with both, starting with 1 and ending with 0. These are three possibilities. Is that clear or not? Is that clear? That means we are trying to frame a string of length 8 bit. So in 8 bit, either it can start with 1 or it can end with 2 0 bits, or it can start with 1 and end with 2 0 bits. These are the three possibilities from that problem we can see. Is that clear? Is that
Yes,
clear or
sir.
not?
Yes, sir.
Yes, sir, Vijay.
Okay.
Uh,
So what are the possibilities in first case? So since this is a bit string, so either one bit can be filled up either with 0 or 1. So if I consider the first case, so the first element is fixed at 1. So remaining 7 positions can be filled up with either 1 or 0. So for the second position, there are two possibilities. So here we can use the multiplication rule. For third bit, there is a possibility of two cases, either it can be 1 or 0. In that way, apart from the first place where we have fixed 1, in other 7 places and each of the places there are two possibilities. So there will be 2 7 times. So total 2 to the power 7 possibilities. Is that clear or not? Have you got it?
yes, sir. বলবেন।
So what is the length of the string? Total length of the string is 8.
8 bit.
Okay, so 8 bit, here I am considering that the first bit starts with 1. So remaining 7 bits can be filled up either by 1 or 0.
Yes.
Yes, sir.
So in the second place there are two possibilities, either 1 or 0. In third place there are two possibilities. In the fourth place there are two possibilities. So each are independent, but after filling up the second place only we can fill up the third place. After filling up the second and third place we can fill up the fourth place, and so on. So all are connected together. So here we can use the multiplication rule. Is that clear or not?
Yes, sir.
So here there are two possibilities. For that here there are two possibilities. For that here there are two possibilities. So total there are 7 places. So total possibilities are 2 to the power 7. Is that clear? Is that clear or not?
Yes, sir. Yes, sir.
Yes, sir.
Now what are the possibilities for second case? Here last two places are filled with 0. They are fixed. So remaining how many places are there? Remaining how many vacant places are there?
2 to the power 6.
6 vacant places are there. So each of which can be filled up with two possibilities, either 1 or 0. So total there are
2 to the power
2 to the power 6 possibilities. So 6 times. So 2 to the power 6 possibilities. So 2 to the power 7 means 2 to the power 4, 5, 6,
128, sir.
and this is 64.
স্যার আর একটা থার্ড কেস হবে 2 to the power
Yeah.
5
There will be one third case, because here it is given that either with 1 or 2. Either or means key. Either 1 can be there or last 2 bit can be 0, or both can be possible, because there are common things. Okay, so that means here first one is fixed with 1, last 2 are fixed with zeros. So remaining vacant places are 5. So each of which can be filled up either by 0 or 1. So there are total 5 possibilities. So that is 2 to the power 5. So that is 32. So unlike the addition rule that I have used in the previous class, there two events are disjoint. So I have told there that there is there are two language groups. In one language group there are 5 subjects, and another language group there are 6 subjects. So if we need to choose one subject, then how many ways you can choose them? So I have there told that in the first group of language subject and second group of language subject there is no common subject, so they are disjoint. So total 5 plus 6, so 11 possibilities are there from which you can choose one. But here we can find that there is also a common connection between the first bit 1 and last 2 bits are 0. So here we can use the inclusion exclusion principle. So what will be our answer? So only one can be filled up in 128 ways. So here in the first case, these cases are also there, because here the first place is 1 and last two places are 0. So we have counted this in the first case. Similarly, while we are considering the last two places are 0, that again I am counting in the third case. So that 32 must be subtracted. Is that clear or not?
Yes, sir.
So total there will
160.
be 160. So this is the example of exclusion exclusion principle. So whenever two sets are given to you where there is no common connection, then if we are asked either from this set or from this set events can be chosen, then we will be using there the simple addition rule. But if there is any common term in between two sets, then we can use there the inclusion exclusion principle. Okay, is that clear? Is it clear to all? If you have any doubts, any queries, you can ask me without any hesitation. Is it fine?
No,
Is
sir.
it clear to all?
Yes, sir.
Yes, sir.
Then I am moving to pigeonhole principle. What it is saying? Say for example, say there are 5 vacant places or 5 holes, and there are 6 pigeons. So this is a pigeon. So there are 6 pigeons. So here the problem is each of the pigeon can be there in one hole. That means one hole means this is their nest. So there a pigeon can stay. So if the pigeon comes back, then all the 6 pigeons will come together. Then what can happen? Each of the pigeon can actually take a one place or one nest. Then there will be one pigeon extra which do not have any single or unique nest. So the 6th pigeon either should be here or should be here or should be included here or should be included here or should be included here. That means if the number of holes are lesser than the number of pigeons, then there will be at least one hole which will contain more than one pigeon. Is that clear? The principle is clear.
Yes, sir.
So similarly, we can use this in the postcard envelopes also. Say for example, there are 6 envelopes. There are 6 envelopes, and there are 7 postcards. Six envelopes. So 6 envelopes and 7 postcards. So here we need to insert a postcard uniquely within an envelope. But here since there are one envelope less than the number of postcards, so if we want to insert the postcards in the envelope, so we will be finding at least one envelope where there will be more than one postcard. Is that clear? So this is the pigeonhole principle. So how we can use this? Say for example, just I am considering one simple example. So in a leap year, so how many days the February has?
29.
29 days. So let's say in your class there are say 61 people or 61 students. Then how many days there is a possibility that 3 students have the same birthday? Have you got my question? Say in a leap year in February there are 29 days. I have told that the 61 students are there in your class and each of you have the birthday in February. Is that clear? Have you got it or not?
Yeah.
Say in a leap year in February there are 29 days, and suppose I am giving one condition that total 61 students are there in your class and each of the students have the birthday in February. Then how many possibilities will be there that, or how many minimum number of possibilities will be there that the 3 students might have the birthday in same day? It may happen that all 61 students have birthday in one day, it may happen. But if I distribute it uniquely, if I want to try, if I would like to try to distribute it uniquely, then what is the possibility that at least 3 students will be there whose birthday will be in a single day? There is a possibility. Have you got my question or not?
Sir, please repeat it once more, sir.
So there are 29 days in February and I have told that all the students who are there in your class, total 61 students are there. So these 61 students have birthday in February. Then what is the minimum number of possibilities there that in a single day 3 students will have born act? Have you got it now or not?
হ্যাঁ স্যার কোশ্চেনটা বুঝতে পেরেছি করবো কিভাবে?
So how you can solve this? So if you use the pigeonhole principle, then 29 students are there. So in each of the day, if I consider the birthday of one student, then there will be total 29 students. Then how many leftover students will be there? 69 minus 29. Then there will be 32 students. Is that clear? Is that
Yes,
clear or
sir.
not?
Yes,
Then
yes.
again out of these 32 students, I can distribute 29 students in each of the day because total 29 days are there.
Yes, sir.
So what will be the leftover students? Leftover students will be 3 students. So again 3 students I can place in 3 single day. So there are least number of possibilities key. There are least number of possibilities that there can be 3 dates where there will be, but there can have the possibility of 3 birthdays.
Yes.
Is that clear or not? Have you got it or not? So it may
Yes,
happen,
sir.
this is
Yes,
a
sir,
possibility because it may happen that all the students have the birthday in 3 days. So all 61 students have the birthday in 3 days. It may happen. But without knowing that, just if I want to count the possibilities, then what can be the possibility that minimum number of students will have born in a particular day, that is 3. So there will be 3 such days. Is that clear?
Yes, sir.
So how we could generalize this? So generalized pigeonhole principle is,
এটা কি হলো একবার বলুন? এটা 29 হলো, 29 এ ডিস্ট্রিবিউট করে দিলাম 29 দিনে 29 জনকে।
then total 61 আছে, 61 থেকে 29 বাদ দিলে কজন পড়ে থাকছে? 32।
32
তো 32 জনের মধ্যে যদি আবার ইউনিকলি আমি যদি ডিস্ট্রিবিউট করতে যাই, আবার 29 ডেজে সবাইকে ডিস্ট্রিবিউট করতে পারি, তাহলে কজন পড়ে থাকবে? 3 জন।
3 জন থাকে।
সেই 3 জনকে আবার কি এক একটা করে দিলে কি 3টে ডেট এমন পড়ে থাকবে যেখানে 3 জন হয়ে যাচ্ছে?
হ্যাঁ হ্যাঁ।
তাহলে মিনিমাম নাম্বার অফ পসিবিলিটিস কত? 3।
আচ্ছা।
তাহলে আমি কি করছি? পিজনহোল প্রিন্সিপাল মানে কি? ফার্স্ট আই উইল ট্রাই টু পুট or I will try to fill up the holes with single pigeons. Then the leftover pigeons will be filled up uniquely again from the initial hole. Then if it gets filled up, then again the remaining things will be filled up in the provided hole. Is that clear? Is that clear or not? যদি একটা বেশি থাকে তাহলে তো হয়েই গেল, একটা বেশি থাকলে একটা অ্যাটলিস্ট থাকবে যেখানে দুজন ফিল আপ হবে। এখানে এরকম হতে পারে, ধরো 6টা পিজিয়ন, এখানে এই কন্ডিশনটা কিন্তু নেই যে ধরো 6টা পিজিয়ন আছে, 5টা হোল আছে, তাহলে একটা হলেই 6টা পিজিয়ন ঢুকে গেল, এটা কিন্তু পসিবিলিটি নয়। আগে আমাকে যতগুলো ভ্যাকেন্ট হোলস আছে দ্যাট নিড টু বি ফিল্ড আপ, দেন দ্য এক্সট্রা থিং উইল বি ফিল্ড আপ ইন ইদার অফ দিস 5 হোলস। হ্যাভ ইউ গট ইট অর নট?
Yes.
So what is the generalized principle? If k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing two or more of the objects. যদি k plus 1 থাকে then only one box will be there where there will be more than one object. But if there are k plus more than k plus 1 objects, then the multiple boxes will be filled up by two objects. Then if all the boxes are filled up with two objects, then again we will start from the very beginning box or very first box. Okay. আচ্ছা বলছি আজকের ক্লাসে I think I could only be able to finish the permutation combination. So next Wednesday is the holiday. So can you tell me one what I can say, one extra time or extra duration when I can take some extra classes? One extra class will be required, 30 minutes or 50 minutes, then I could finish it. এমনি তো যখন ক্লাস পিরিয়ডের মধ্যে তো সবারই ক্লাস থাকে, কেউই তো এখন নিশ্চয়ই ক্লাস দেবে না আমাকে, তো কখন নিলে সুবিধা হবে? তাহলে এটা ভালো করে পড়ানো যায় আর কি, নাহলে আমি চটপট দুমদাম পড়িয়ে দিই, এমনি তো তাড়াহুড়ো করে পড়াতে হচ্ছে।
স্যাটারডে নিয়ে নিন,
স্যাটারডে নিতে পারেন স্যার, স্যাটারডে সানডে তো আমাদের ছুটি থাকে, আপনি ওই টাইমে নিয়ে নিতে পারেন।
তাহলে স্যাটারডে কখন বলো, তাহলে সেটা গুগল ক্লাসরুমে লিখে দেবো।
স্যার মর্নিং এই থাকুক,
নাহলে ইভিনিং এ কোনোদিন হবে, মানে উইকডেজে ইভিনিং এ?
হ্যাঁ স্যার
ইভিনিং হবে।
তাহলে আজকে তো ক্লাস হলো, মানে কবে তোমাদের মোটামুটি ক্লাসের লোড কম থাকে বা ইভিনিং এ ক্লাস থাকে না বলো, তাহলে সেরকম নিয়ে নাও।
স্যার কোনোদিনই এরকম থাকে না স্যার, স্যাটারডে সানডে নিই, ওই দিনটা আমাদের হলিডে থাকে, ওটাই সুবিধা হবে, বাকি দিন তো ক্লাস থাকে।
স্যাটারডে সানডে যখন তখন নিতে পারেন,
যখন তখন আজকেই বলে দেবো তাহলে টাইমটা, সেটা বলো। স্যাটারডে তাহলে কখন?
হ্যাঁ আপনি
10টায় নিলে হবে? স্যাটারডে 10?
একটা টাইম বলে দেবেন তাহলে হবে।
ঠিক আছে, তাহলে আমি গুগল ক্লাসরুমে বলে দেবো স্যাটারডে 10 AM থেকেই নেব, ঠিক আছে? 10টায়
9টা স্যার 9টার থেকেই নেন না?
ঠিক আছে 10 AM,
আর 10টায় নেই আর কি, 10টায় নেই তাহলে সবাই।
হ্যাঁ 10টা ঠিক আছে, 10টা।
হ্যাঁ তাহলে একটা ক্লাস নিলে মোটামুটি তাহলে ভালো করে পারমুটেশন কম্বিনেশনটা পড়ানো যাবে আর কি, না হলে তাড়াহুড়ো করে পড়ালে ভালো হয়। ঠিক আছে, তাহলে স্যাটারডে 10টায় নেব আমি বলে দেবো।
একটা রুম ক্রিয়েট করবেন তাহলে নাকি?
না না, এই লিংকেই নিয়ে নেব।
না না লিংক পাঠিয়ে দেবে আবার।
না না, লিংক পাঠাবো না, আমি এই লিংকেই নিয়ে নেব।
ম্যাম সৌমি ম্যামের এ লাগবে তো।
কি লাগবে
ম্যাম? স্যার এই লিংকে নিলে আবার মানে অ্যাকসেপ্ট করা যাবে না তো।
এখন অ্যাকসেপ্ট কে করে?
স্যার আপনি সৌমি ম্যাম করেন।
সৌমি ম্যাম করেন
এখন তো আমরা তো কেউ অ্যাকসেপ্ট করলো না, আমরা তো এমনি ঢুকে গেলাম
ক্লাসরুমে।
এখন তো স্যার অ্যাকসেপ্ট করা আছে অলরেডি, তো আপনি যদি নতুন লিংক ক্রিয়েট করে তাহলে না আপনি হোস্ট হবেন, আমাদের অ্যাডমিন।
ঠিক আছে, তাহলে আমি ওই গুগল ক্লাসরুমে দিয়ে দেবো, ঠিক আছে স্যাটারডে।
হ্যাঁ স্যার,
হ্যাঁ স্যার ওটাই ভালো হবে।
তোমার তো কোনো হোয়াটসঅ্যাপ গ্রুপ নেই এমনি আলাদা আছে?
নেই স্যার।
নেই স্যার ওরকম।
ঠিক আছে, তাহলে আমি গুগল ক্লাসরুমে দিয়ে দেবো স্যাটারডে, তাহলে 10টায় নেবো, ঠিক আছে? Okay, then I am giving one problem. I think you know what do you mean by the 1-1 function, no? 1-1 mapping. Are you all familiar with 1-1 mapping?
Yes sir.
What is the 1-1 mapping? 1-1 mapping means whenever we are defining a function, in the previous class I have defined the function. So whenever we are defining the function actually maps each and every element of domain to some elements of codomain. So what is the definition of function? Definition of function means each and every element must have a image in codomain. So if more than two elements are mapped to the same element, that means there are two different students. whose address or whose home is same, it may happen. So this is called as the many-one function. So one-on mapping means corresponding to each element in the domain, there will be a unique element in the codomain. That means two elements will not be mapped to the same element. Is that clear? Is that clear or not? What is the one-on mapping?
Yes, sir.
One-on mapping means more than two elements cannot be mapped to single elements. This is many-one mapping. One-on mapping means each and every element of the domain must be mapped to a unique element. So here by using the pigeonhole principle, we could check whether a given function is a one-on function or not. How? Let's say, let us consider one problem. A function f from a set with k plus 1 or more elements to a set with k elements is not one. So that means what we have told, say for example, this is let's say domain. In the domain there are k plus 1 elements. In codomain there are k elements. So here I need to show that if I define a function from this set to this set, where A is the domain and B is the codomain, and the set A is having k plus 1 element and the set B is having k elements, then I am telling here that there cannot be any function f which will be mapped from this A to B, that is 1 1. That means f cannot be 1 1. How I can prove that? So by pigeonhole principle I can prove that. So there are k plus 1 elements and there are k elements. So here I could consider that in the set A there are k plus 1 pigeons, the k plus 1 pigeons, and in B there are k number of holes, there are k number of holes. There are k number of holes. So here each and every pigeon I could map to a particular hole. That means this pigeon is mapped to this hole, this pigeon is mapped to this hole, this pigeon is mapped to this hole. So uniquely if I want to map each and every pigeon to a particular hole, then there can be k such choices, because k pigeons can consider or can be actually put here in k number of holes. So there will be one leftover pigeon. Is that clear? Is that clear or not?
Clear, sir?
Yes, sir,
So
clear.
if I need to map this, because whenever I am defining this function, then each and every element of the domain must have a definition. That means each and every element should be defined. So no element should be here in the domain without any definition. That means without being mapped with some elements in the codomain. So this leftover element must be mapped to any of the holes. So if it is mapped to any of the holes, let's say I have mapped to here, then this is many-one mapping, because both the elements are going to the same definition. That's why this will be obviously many-one. So if a domain contains more elements compared to the codomain, then we can't define a function which will be one-on mapping. So this is example of, or this problem can be sorted out with the help of pigeonhole principle. Was that clear? Have you got it or not?
Yes, sir.
Okay. So
Yes, sir.
Saturday I will be taking one extra class where I will be discussing permutation and combination. After that, since you are telling, so I will give some model questions in the Google Classroom, so that you could take preparation for the first semester examination. Okay.
Okay, sir. Thank you.
So let me take the attendance. সো আর ইউ ফেসিং এনি প্রবলেম? কোনো বুঝতে অসুবিধা হচ্ছে যা পড়ালাম, যতদূর আমি পড়িয়েছি প্রথম থেকে?
না স্যার।
না তাহলে তোমরা বলছো না যে সাজেশন? আমি সবই তো আমি করিয়ে দিয়েছি, মোটামুটি বলে দিয়েছি।
আমার সাজেশন না, মানে কোনো আইডিয়া নেই তো স্যার যে এখান থেকে কিরকম কি কোশ্চেন আসবে, আর ম্যাথের সাথেও সেইভাবে টাচে সবসময় থাকা হয় না।
করে দিয়েছি তো আমি, ক্লাসে বলে দিন। ঠিক আছে, আমি দিয়ে দেবো। রোল নাম্বার 1,
Yes, sir.
2,
ইয়েস স্যার।
3,
Yes, sir.
4,
Yes, sir.
5,
Yes, sir.
6,
Yes, sir.
7,
ইয়েস স্যার।
8,
ইয়েস স্যার।
9, 10. Roll number 10, 11,
Present, sir.
12,
Present, sir.
13, 14,
Present, sir.
15,
ইয়েস স্যার।
16,
Yes, sir.
17, 18,
Present, sir.
19,
স্যার 19 ক্লাসে আছে, ওর নেটওয়ার্ক ইস্যুর জন্য মাইক অন করতে পারছে না।
20, 21,
প্রেজেন্ট স্যার।
22, 23, 24,
Present, sir.
25, 26,
Yes, sir.
27,
Sir, 23 present, sir.
27 আছে, 27 লাস্টে বলবে। আমি 27,
হ্যাঁ 27 চারটে লিখেছো প্রেজেন্ট আছে।
28, 28, 29, 30,
Yes, sir. 30.
23 বললে না? 23,
Yes, sir. Yes, sir.
31, 32,
প্রেজেন্ট স্যার।
33,
Present, sir.
34,
Yes, sir.
35,
Present, sir.
36,
প্রেজেন্ট স্যার।
37,
প্রেজেন্ট স্যার।
38,
Present, sir.
39,
Yes, sir.
40,
Present, sir.
41, 42,
Present, sir.
43, 44,
Present, sir.
45,
প্রেজেন্ট স্যার।
46,
Yes, sir.
47, 48,
প্রেজেন্ট স্যার।
49,
Yes, sir.
50,
প্রেজেন্ট স্যার।
51, 52, 53,
Yes, sir.
54,
52, sir.
54,
ইয়েস স্যার।
53 আছে, 53,
না স্যার, কলেজেই নেই ও।
$55,
Present, sir.
56,
Present, sir.
57,
Yes, sir.
58,
Yes, sir.
59,
Present, sir.
60, 61, 62,
sir.
62,
Sir, 47 present. Hello, sir.
হ্যাঁ ঠিক আছে
Sir, 47 present.
দেওয়া হয়েছে 62 আছে 62 ঠিক আছে okay so Saturday from 10 a.m. I'll be taking one extra class, so I'll be sharing the link in the Google Classroom, so all of you should check the Google Classroom for notification, and I'll be giving there the link. Okay, so thank you all. So I am sharing this
Thank you, sir.
today's handwritten class note link in the Google Classroom, so you may create create an account in Evernote and can access that. Okay, thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, good afternoon, everybody.
Good afternoon, ma'am.
Okay. Okay, so I will continue from where I left. So that portion is clear to all?
Yes, ma'am.
Everybody, that portion is clear how to find the minimal cover? Okay, so now I will give you an algorithm